into Technical Essential. Today, our topic is CloudWatch. So let us dive deep into it. So introduction to monitoring. Now, if we simply say, right, what is monitoring? It is the process, right, of continuously observing, right, the health, performance, and say availability or security, right, of our applications, right, network or our cloud resources, right? Not only say cloud resources, your on-premises resources as well, right? Now we can monitor any resource, right? That say we deploy. So monitoring is keeping close eye, right, on the status, right, current status of your resource, right? So why again, if we say right, why we monitor? So we monitor, right, so that we can detect issues, right, early, right, before, say, it impacts the customer experience, right, the user experience, right? So, okay, why monitoring matters in the cloud? First, the operational visibility, right? So it gives operational visibility, right? We can see what is going on, right? Because once we deploy our resources in cloud or on-premise infrastructure, right, there is nothing much, right, to see what is going on, right, which resources are running, what is current status, right. So this operation, right, monitoring gives this operational visibility to understand exactly, right, what is happening across your resources, right. So, for example, like from CPU usage, right, on EC2 to database connections in RDS, right. So you can see that, okay, how much, right, currently, how much CPU is being utilized by your EC2 instance, right, based on current demand. So whether it's 50%, 60%, 80%, right? So based on this data, what you can do is you can make decision, right? That okay, if it is going say over 80%, that means okay, it must right, we must launch new instances. Otherwise, right, maybe once it gets 95%, maybe beyond that, our server may get right crash, right, it will start throttling. So definitely if it is going beyond such, right, CPU capacity, then we can make a decision to launch new instance, right, otherwise it will impact users, right, if it is reaching uh, say over 95%. So before it reaches that level, we will launch new instance. Then also, right, we can track, right, what is currently, right, current ongoing connections, right, to our RDS instance, right. So this way again we can track that number of live connection to our databases, right. So we can see if there is any anomaly, right, and we can also, right, based on that we can also decide, right, which performance type, right, how, right, to select, right, provisioned or right or on demand, right. Just like yesterday we discussed for NoSQL, right, DynamoDB, that we have different modes, right, provision modes and the on-demand mode. And so definitely based on these data, right, from CloudWatch, we can decide that how we should go further, right? So also optimization, right, and cost. So we can identify underutilized resources, right, to save costs and detect performance bottlenecks, right, before they affect end user. So definitely, when we see and right our infrastructure, we are getting right live feeds, right, live data from our resources deployed. We can reduce cost by eliminating, say, resources. Maybe they are just lying idle, right, from long. So we can see, okay, if this EC2 instance is just right being used maybe 5% or 10%, right, at most, and there are, right, the average CPU utilization is also below say 50%. So definitely we can get rid of instances, right, that is being used, right, say just 5%, right? So it's almost right idle, right? So maybe there are other instances that is lying completely right at 0%, right? CPU utilization, right, near zero. So definitely, monitoring right will tell us that which resources right are just right lying idle without being utilized, right, without accessed. So we can cut down right those resources to save cost, right? And also we can see right performance bottleneck. Maybe say uh, to connect to your web server, it is taking right maybe say normally, right, maybe it is taking, say, 100 milliseconds. Now, you're saying that, right, currently it is taking over 2 seconds, right? Now, so based on that, right, what you can do is you can optimize, right, your application, right? So, uh, CloudWatch or monitoring, right, will give us, right, this data, right, metrics that we can work on, right, to fix to, right, improve the performance, right? So also, right, we can plan for the capacity as right based on say the utilization of CPU, right? So if your CPU is going beyond right certain levels, if more than 80%, okay, let's launch new instance, right? So it helps us to plan for new right requirement for the capacity. Reactive versus proactive monitoring, right? So what is reactive? Reactive is something right we wait for problem to occur, right? So like a server crash and then scramble right to fix it, right? Increases downtime, right? And user frustration. Definitely a reactive, right? Once something is already happened, right? We are taking action. So definitely that is not the right way, right? To solve right issues or problems. So what we need to do is we need to right go for the proactive solution that right we solve the issue before it impacts the user experience, right? Because if we are going for reactive, definitely if the server is crashing it right first and then we are fixing it, so definitely there will be a lot of downtime, right, for the user, and definitely it will increase the frustration for the user, and also it will right have right them leave right and go for the competitor, right? So definitely the proactive monitoring, right, it analyzes the trends and set thresholds, right? Receive alerts when a resource is approaching capacity, right? That is the maximum, right, capacity, and allowing, right, preemptive actions, right? That okay, before crashing, they can launch new instance, right? So they will not wait, right, for the server to crash. So definitely, this is right proactive monitoring helps us, right, to solve issues before it impacts the customer experience, and definitely it will right make your resources or infrastructure highly available, right? So definitely if there is a low downtime, there will be a high availability, right? The uptime will be maximum. So CloudWatch, so what is CloudWatch? It is a monitoring service, right? Monitoring and observability service built for DevOps engineers, developers, right, or IT managers. So from right, it provides us a dashboard, right, from which the owner, right, can take decision, right. So it provides data and actionables, right, insight to monitor applications, respond to system-wide performance changes, and optimize resource utilization. Right, so definitely it is basically giving us right data in a dashboard, right? Right, as we want in graphs, we can see, and from those graphs we can make decision, right? So basically It collects, right, and tracks matrices, logs, right, events, and also, right, the application performance data. So here, key benefit and capabilities of CloudWatch. So unified view. So it gives us, right, visualize, right, help us to visualize the infrastructure and application health, right, in single dashboard. Right, so we can create a dashboard, right, our custom dashboard also, and we have default, say, matrices, right, or dashboards that we can use to visualize, right, the current, say, status of our resources, right. Automated response. Now, based on, right, you can also trigger, right, automated action based on certain, right, threshold breach, right. So on metrics or log events, right, based on your metrics that you're tracking, right. So basically, if I say what is metrics, right, it is numeric data points, right, collected over time, right? Maybe if we are saying CPU metrics, that means it is data related to CPU, right? That okay, what is the current CPU, right? Usage. So it's say 40%, right? So at every data points is again the frequency, right? At which you are actually fetching the data, right? From the EC2 instance, right? Now how it works? Now, CloudWatch, right, is actually running its agent, right, in the instance, right? That is, we call it, right, CloudWatch agent. Now, this agent is forwarding that data, right, to CloudWatch, right? And based on that data it is receiving from its agent, it is creating, right, all those graphs, right, and everything. Okay, at this point of time, the CPU utilization is 50. Now, 5 seconds right later, the CPU utilization is maybe 51. So it is sending, right, your CloudWatch metric, your CloudWatch agent is sending all this data to CloudWatch, right? So and it is right, accumulating it is, right, and creating, right, a dashboard, right, out of that data. So the frequency that we select, right, based on that, right, there is, right, by default you get some, right, frequency that is okay. Every 5 minutes you will be receiving the data, right, from the agent. Now, again, based on that, right, based on frequency, if you want, right, more frequently, right, you want, say, access to these metrics, right, like maybe per second, every minute, then you need to pay for it, right? So for CloudWatch, right, it's again a paid service, right? When we use custom metrics, right, and if we are using the default one, maybe, right, that is sending you data metrics, right? Say data every 5 minutes or say 15 minutes, right? So a few of the, right, such metrics, right, default metrics are free, right? During your free tier, say eligibility. So it provides you, right, native integration, right? Seamless collects, right, data from 70 plus AWS services, right? So it almost now, right, close to 100, right, or more than 100 AWS services now, right? Very common with EC2, S3, Lambda, RDS, right? So it can collect all these data, right, from these services. So root cause analysis. So correlate metrics, right, and logs to quickly find issues, right? So we can compare, right, and correlate these logs and matrices to fix issues, right, to identify that what is wrong, right, what is going wrong in the, right, say, infrastructure, right, in that particular, say, resource, right. So, metrics, logs, and alarms, right? So, let's see what is this. So, currently, right, your CloudWatch metrics, 100 plus integrated services available, quantifiable performance. Now, again, one thing to note here, So when I say it is right, it is receiving the data right from the CloudWatch agents, right? Now you can right also monitor your on-premises resources, right, from CloudWatch. So it supports right, it can access because you can install CloudWatch agent right in your on-premises servers as well. Now, if you are installing CloudWatch agent in your on-premises server, then it will right send the data right to CloudWatch. So you can right use CloudWatch to monitor your on-premises infrastructure as well, right? So it can right you can use it to monitor your cloud infrastructure as well as your on-premises infrastructure, right? Using CloudWatch agents. Now, so again, quantifiable performance data metrics, right, are time, right, ordered set of data points. Think of right them as the variables you want to measure, right? So it will automatically right create say that right say the frequency again what we were talking about, right? So every say second or every minute, every 5 minutes, every 15 minutes, right? So these are timely, right? It is having that frequency, right, at which you will actually get right receive the data right from the agent. So think of right the variable that is just filling right the values right of that variable. So standard metrics, right, are provided by default, right, and custom metrics can be pushed right via the CloudWatch agent or API, right? So we can create custom right matrices and also right set the frequency right at which it will receive data right from those agents, right, or through API. So common AWS resource metrics. So for example, service right, Amazon EC2. Key metrics, we have CPU utilization, right? So what it gives us, it tells us, right, the percentage of allocated, right, EC2 compute, right, units currently in use, right? So this is percentage of allocation, right, of EC2 compute. So compute is basically, right, it is the CPU utilization, right? So currently in use. So if it is currently using 50% of your CPU, then it will right send the agent, the CloudWatch agent, right, will be sending 50 for right say again for after 5 seconds 51, after right next 5 seconds 53, after next 5 seconds. So every 5 seconds. So based on the frequency, it will send right. It will get the data from the agent, right? So that will be fixed once you fix right uh, uh, your frequency. The data points will be right updated right as per the frequency that is set right by default. The one that right generally are used right the default one so is basically 5 minutes, right? And also it can go 15 minutes, but if you want right say more frequent data maybe every minute, so you need to pay for it, right? For that you need to create custom metrics, and also right you can change the frequency to 1 minute and also less than that, right? So you can do every second also, but definitely the more frequent right access you want, so more right you need to pay, right? So Amazon RDS, again for RDS key metrics we have that is database connections, right? So we can see the number of client sessions right currently connected to the database, right? So we can see active connection that is ongoing, right, with the database. Definitely based on that we can right take decisions that okay what capacity right we need to handle right such say traffic, right? So in future maybe with this right current scenario, current trends, we can right predict that okay what kind of demand we will be getting right next, right? Maybe right. So that we can see for AWS Lambda, say key metrics, we have errors. right? Now, number of function, right, invocations that resulted, right, in error, right? Now, Lambda is a serverless service, right? It is a serverless service. So we don't have to manage the underlying resource, right, ourselves, right? So that is why we are calling it serverless. So, right, through this error metric, what we can do is we can track, right, for errors, right? That okay, whenever say the Lambda function is getting evoked, right? So, it is basically right. It runs based on triggers, right? So you need some event to trigger the Lambda function. Now that trigger is the invocation. Right now, if a Lambda function is getting invoked, but it is not responding, right? It is failing to respond. So definitely, right? It will throw an error. So it can track, right? Your key error metrics, right? Can track that, right? Such events, right? Okay, whenever the right error occurred, so right, so it can track that, right? So definitely based on that, right, we can make decision, we can optimize, right, the function and check, right, we can find out, right, the root cause, why it's doing so, right, why it's failing, why it's throwing us the error. Then say for service, right, Amazon S3, we have, right, key metrics is bucket size bytes. Now what it will do, it will, right, the amount of data stored, right, in an S3 bucket daily, right? So it is going to give us, right, that data, and then based on that, definitely we see, right, that okay, what is our current usage, right? The usage goes up. Now you remove data, right? It will go down, right? So based on your byte size, right, bucket byte size, right, it will show you that right, your usage metrics, right, how you're using your S3 bucket, right, daily, right? Maybe throughout 24 hours, right? What is the status, right, of your usage, right? So if there is any addition or right a deletion, right, of the objects from your bucket, right? So it will track all the, and it will send, right, the metrics, right, data back to CloudWatch. So then coming to CloudWatch logs. Now, what are logs, right? We understood metrics, right? Metrics were, right, the data that it was receiving, right? So it was a numeric data point, right, that was collected over time, right? Now, your CloudWatch logs, right? So log is basically, right, it is information, right, more detailed information, let's say qualitative insights, right? So while metrics tell you, right, that something happened, logs tell you why it happened, right? So it is going to log that event with more details. So CloudWatch, right, logs allow you to monitor, store, and access log files from your EC2 instance, CloudTrail, right? So Route 53, right, or other sources, right? So you can, right, you can pipeline, right, you can send, right, or say export your logs from different services to CloudWatch for analysis, right? So definitely when we analyze the logs, right, we get to know that what actually happened, right? If there is a server, right, that crashed, right, so it may, right, have already updated, right, in the log that okay, what went wrong, right? So search, right, for say specific pattern, right? So example error 404, right? So and trigger, right, alarms based on log, right, occurrences. Now, whenever we are pushing say logs, right, to CloudWatch, we can, right, raise an alarm, right, or whenever it is, right, say breaching certain threshold that you have set, that okay, if it right, in the log file, if you find this keyword, right, say error 404, say more than 5 times, right, so you want to trigger, right, an alarm, so it can notify, right, the admin for such, right, errors, that okay, it is getting, right, these keyword, right, in the log, right, multiple times, more than the threshold, right? That is, say you have set it for more than 5 times, right? So if it is getting more than 5 times, it will alert the admin that okay, you need to have a look, right? There is something wrong, right? And you will see, you'll get right more details that okay, what happened, why it happened, right? Say which user maybe, right? Someone tried to connect and got error 404, right? Not found, error, right? So these things, right, we can look for, right? And so we don't have to manually, right, analyze the logs manually, right, going through each and every line. So we can push the logs to CloudWatch logs, right, from our resources, and it can analyze the logs, and it can give us, right, the say alerts, right, and based on that we can take, right, a decision. How these logs are organized. Now, logs are organized, right, generally in log groups or log streams. Now, what is log group? So basically, a log group, right, is a collection of log streams that share the same retention, monitoring, and access control setting, right? So, for example, the AWS Lambda my function, right? So everything, right, that is happening, right, for, inside say that particular function, it is creating a log group, and right, it is say keeping everything, right, all the logs, right, for that particular function inside that particular log group, right? So also, right, if you have, right, some multiple functions, right, and they have the same say retention and monitoring, so it will have, right, all those logs in that same log group, right? So then in log streams, it is a sequence of log events, right, that share the same source, right? Say, for example, such as specific say EC2 instance, right, or an individual container task, right? So if the source is same, right, so if that it is the say, that specific say prod EC2 instance, so whatever log it is receiving, it will be inside its log stream, right? So a different log stream will be created for different sources. Now we have a lambda function, and right, that lambda function is getting triggered. Whenever it is getting triggered, it will be, right, creating a, right, log stream, and inside that log stream, right, it will, you can see what is going on, right? So whether say that lambda function it got executed successfully or there was a failure, right? So if it got executed successfully, whether, right, what was the status code, right, and say what happened, right? So all these things, right, will be what was the output and everything will be, right, shown in the log stream, right? So for every source, right, different source, it will create, right, a different log stream. Now, if you compare, right, the metrics versus logs, so definitely they both, right, uh, have, right, their own roles. So metrics, right, structured generally, right, metrics efficiency is high, right, because it is giving us, right, the actually, right, uh, real-time data, right, from our say uh, our resources, right? And log is basically, right, it is unstructured, and the detail, right, is high, right? So definitely metrics is right, efficiency high, right? We can optimize, right, the performance and everything, right, from the metrics. So it tells us, right, basically uh, what happened, right? So and log, right, is basically it is more detail oriented. We can see why it happened, right? So what happened versus why it happened. So metrics is telling us, right, what happened, and log is telling us why it happened, right? So it is more detail oriented, and definitely that is why we are using it, right, to say troubleshooting, right, whenever something goes wrong, first thing, right, that we see is the logs, that okay, what is there in the logs, right? Because we understand more, right, that okay, what happened, why it crashed, maybe, right? So for that, we visit these logs that were created. Now, the metric storage cost definitely low if you are, right, considering metrics. When we create custom metrics, it will, right, cost less than the cost of the logs, right? The when we are storing logs, right? So it is again depending on the frequency, right, of it. So if it is you are collecting, right, or storing logs, right, very frequently, or right, based on events, so definitely the more log, right, you collect and store, more you pay, right? So definitely it is more than at least the metrics, right, that will cost. So use metric for real-time dashboards, right, and use logs for deep forensic analysis, right? So when you want, right, to know what exactly happened, you should go with the logs. And when you want to see, right, say you want to have, right, the a clear visualization of your infrastructure, right, in and say real time, you can go for metrics. So then coming to CloudWatch alarms. So in CloudWatch alarms, we generally have three states: okay, alarm, and insufficient. Now, what are these? So first of all, CloudWatch alarm, right, is uh, uh, alarm, right? It monitors your metric, right, and perform actions when thresholds are crossed, right? Now, just now when we discussed, right, that okay, whenever, right, say the CPU utilization, right, is breaching certain threshold, your RDS may be concurrent, right? Date connection is breaching certain threshold. Maybe, right, your CPU utilization is going above 80%, and when it reaches 80%, what you want to do is you want to raise the alarm, right? You want to alert, right, the admin that okay, you should, maybe you are launching, right, you are deploying resources manually. Then okay, once it reaches 80%, you will get a trigger, and the alarm will be raised, and based on that, what will happen is you will be launching your resource manually, right? So CloudWatch alarms, right, have three states. Number one, right, you are okay, alarm, and insufficient. So generally, right, when we see okay in CloudWatch alarm, it is the metric, right, or expression is within the defined threshold. That means okay, say the CPU utilization, right, the threshold is 80%. If it is going over 80%, then it should raise the alarm. So if it is within that threshold, that is, it is below 80%, right, so then it will show you that the current status is okay, right? It will show okay, all right, systems are then normal, there is no, right, breach, right? Still there is no breach, right, for that particular, say, threshold. Then it will show you in alarm, right, in alarm, when the metric has crossed the threshold. So when it is going beyond, right, 80%, so it will trigger, right, say, automated action immediately. Now, generally, right, when it triggers, we have, right, we configure the SNS service to send the alert directly to the admin, or say owner, or maybe the developer, right? So whoever, say, owning that particular, right, say, service, right, will be sent, right? The trigger or the alarm, right, or alert will be sent, right, to them, right? So this will raise alarm, and they can take the decision, or you can also automate, right, the actions, right? Okay, if alarm is being raised, then what action it will take, right? So generally when say we create auto scaling groups, right, we know that okay, based on demand, our resources can grow automatically, right? It can deploy new resources automatically based on demand. So if demand increases, so it will deploy more instances. Now, how it is actually say creating or deploying more instances? Because of the alarm, right? So it is raising the alarm because it is going beyond certain threshold, and from your say auto scaling group is responding to that alarm, right? It is responding to that alarm, that okay, so alarm got breached. That means the threshold that was CPU utilization is going beyond 80%. I need to launch new instance. So it will take the action, right? And it will launch the instance in the say auto scaling group, right? So we can automate the actions as well, right? And then the third status that we see in CloudWatch or the component is insufficient. Now here the alarm has just started, or the metric is not available, not enough data points. Right, definitely when we are creating say these CloudWatch alarms, and it is still just now we launched it, so definitely it is not having all the data that it requires to tell us whether it is okay or it is in alarm, right? It is having not enough access to data yet. So now after it receives certain amount of data, that is from multiple data points, so it will say okay whether it got breached or not, right? So if it so after some time, generally say it takes around 1 minute or 5 minutes to show us whether it is in say okay state, or it is, if it is within that say 5 minutes it is breaching the threshold, then it will show us that okay it is in alarm, right? But if it is just now, just recently you have created your CloudWatch alarm, then it will show you insufficient, right? So it is waiting for more data from the resource. Now once it receives data from the resource, only then it can tell you whether it is in uh, okay or normal state, or it is in alarm, right? So alarm generally we see for auto scaling, or maybe automatically based on certain say triggers. You want to maybe run another say uh, a function in lambda, lambda functions. So definitely for remediation, so maybe there is a your EC2 instance is crashing. So once it crashed, now maybe your CloudWatch is actually monitoring. So based on that crash, it can redeploy, it can trigger a lambda function, and the lambda function, you have the say script to launch new EC2 instance, right? So you can remediate, you can automatically remediate, whatever say whatever action you want to take, right? If the alarm goes off. So visualizing a threshold breach. So here you can understand from this one, say for this time in the y-axis, you can see there is a time. So say in minutes, so you will be having data points, say if you are collecting data symmetrics, your every minute, that is the data point, that is the frequency. Now if it is going beyond, say here is the threshold, you have set is for 80%. So when it is going beyond that 80%, what it will do is before, when it is lying under 80%, that means your current status of the alarm is okay, it is okay. But when it is crossing this threshold, that is it is going over 80%, then it will change it to alarm, right? So when metric CPU stays below this red line for X period, the alarm state, and definitely when it goes above the threshold, it right, changes to alarm. Right, and definitely, excuse me, just a second.
Yes, sorry, take your time.
Yeah. So, when right, it is not like this, right? That okay, it just made a spike, right? For a second, right? Maybe right due to definitely right due to any reason, right? We can get a sudden spike, right? Maybe for 1 second, it just more, or for say few milliseconds, right? You just breached that threshold and it came down, right? Instantly, so that will not get considered right as a breach, right? So it should sustain for some time, right? Maybe for a single right data point, maybe for 1 minute, right? Maybe for 5 minutes. It is again you need to right set that right. Okay, based on what right you want to say change the status right to in alarm, right, in alarm. So when you want to raise it, so if it is sustaining for right say 1 minute or say 5 minutes, right? So based on again the resource, right? How critical it is, right? To right you, right? So maybe right in 1 minute you may get it can go beyond right the critical line, right? So definitely for that, right? You need to trigger it right before that. But you see here it is breaching right the alarm. So here at this point now here at this here right is alarm is getting triggered, right? So it will wait for right certain data points, right? And then it is going to, and similarly, right, the auto scaling group that we right configure. So there also we see that okay by default, right, it will trigger right a scale in or scale out events, right, or it will breach right when it breaches the threshold. So and it will right it will wait for a certain right say minutes, right, say 1 minute or 3 minutes or 5 minutes, and after that it will right actually launch new resource, right? After that it will launch new resource or it will terminate your existing one. So here we go, the example, right, automated scaling. Now easy to install, right? So monitor EC2 instance publishes right CPU metrics to CloudWatch. Now again, it is publishing through CloudWatch agent. Right now, detect so CloudWatch agent alarm detects CPU say greater than 80%, right, for 5 minutes. Now you see it is sustaining for 5 minutes, right, over 80%. Now what it will do? The action alarm triggers right auto scaling group to add instance. Now it sustained right over 80% for 5 minutes. So it is taking now it is right taking action that okay it is triggering the auto scaling group to launch new instance right inside auto scaling group. Now, once it launches new instance, what you are doing is you are notifying that okay, you have SNS service right configured. So it is sending emails right or Slack notification right to DevOps team that okay, there is a scale out event happened right. So it launched a new instance, a new resource in the auto scaling group, right? So definitely when it is breaching the threshold, right? So at that time also you can right send the notification that there is right the alarm got triggered, right? And definitely if you are creating right auto scaling group, then it will automatically launch the new instance. But if you are not using right auto scaling group, then whenever right the alarm goes off, right, so it will send say it will directly notify the right right developer or right operation team to launch right new instance right manually. So CloudWatch best practices: set billing alarms. Very important, right? So always set an alarm for right estimated charges to avoid bill shock, right? So this is definitely a bill shock because As I told you, there are lot of right previous students, right? They had these experience with right big bills in their AWS accounts, right? So definitely, if we set right billing alarms, then before it goes right beyond certain right say limit or budget, it will right send the alert right to the owner that okay, you need to look out, right? There is maybe right your budget was say $10, it is going beyond that maybe, or you already reached right say 50% of the budget. Now it will send you right notification, right? It can also send you SMS. But again, when we configure SNS, right, uh, 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 every month, right, we have 1000 emails, right, for free, but SMS, right, will cost you money, right? So if you are creating, right, during your free tier eligibility period also, right, need to check right whether SMS is right available or not, right, in the free tier, because in previous old accounts, right, SMS is not available, right? SMS is not available, SMS is chargeable, but you can have right around 1000 emails right per month free of cost, right? That means yeah, you can configure your SNS topics, your SNS service, simple notification service, and you can send email right alerts to right the owner uh, uh, right without any cost. So use detailed monitoring again, right, for critical apps. Now this is what right detailed monitoring is, right? So enable 1 minute metric, right, intervals. Now 1 minute metric intervals are again paid, right? These are paid monitoring, right, service, right? So default is 5 minutes. That is free. Right now, again, it is not available for every service, right? So, say for example, for EC2 instance, right, is giving out right all those CPU utilization, right, data, right, every 5 minutes. That is free of cost, right? But if you are monitoring it, if you are enabling detailed monitoring, then right, it will go for right. You need to enable it, and it will get right more data right in less time, so every minute it will be receiving data, and definitely so for each right say push right you need to pay, right? So for each count, so then you have composite alarms, right? So combine multiple alarms, right, to reduce notification noise. Definitely, so you don't have to get notifications, right, for each right different matrices, right, separately. So you can create right a composite alarm where you will get right combined alert, right? So you will not have right multiple notifications, right, or alerts for the same kind, right, or event, right? Maybe the dependent events, right? So then log retention, again set right expiration right policies for log groups, right, to optimize cost. Now definitely when we are logging right these applications or right data. So it is actually right taking up storage, right? So it is consuming storage. Now we need to set right that okay, how long we want to retain these logs, right? How long we want to keep it, right? Because the quickly right we get rid of them, definitely we will cost right. We will save the cost right on the storage, right? So we should uh, manage right. So log retention period and to optimize right the cost, right?